Spark, number of executors versus executor memory versus executor cores versus driver memory. So in Spark we have nodes. These are the machines. On the nodes we have executor, where each executor is a JVM. Each executor can run multiple tasks. It runs multiple tasks according to the number of cores. However, if we specify in the configuration number of cores which is larger than the available cores, then of course not all of them would really be able to run in parallel. So the most parallelization would be if we have a Spark a task per core and multiple Spark executors on multiple JVM machines. So again, the top-down hierarchy is that we have a global Spark cluster. On the global Spark cluster, we have a single driver node. And then for the driver node, we can specify how many CPUs, how much memory do we have. And why do we need to specify how much memory we want on the driver node? Because the driver node would eventually get the results. If the results that we get back to the driver node, and of course we should try to get only aggregations to the driver node such that it would be small. After all, why are we doing Spark? We are doing it because we have a large amount of data, but it's not always the case that we can really reduce the amount of data to get back to the driver node to be that small. So in some cases we need to increase the amount of memory on the driver. The driver is the main machine, the thing that runs the main code, and then we are splitting the code into multiple machines to run on multiple partitions. In order to specify the amount of memory that we have on the drive, then we use the driver memory and configuration. And similarly, we also have a configuration named executor memory. The executor memory will control how much memory each executor has. And as we said, an executor is not a machine, is not a node. We have a node, and on each node we can have multiple executors, where each executor is a JVM, and on each executor we have multiple tasks. So it's a node that has multiple executors, that has multiple tasks, where each task corresponds to a core. And how many tasks are we going to have? That is going to be determined by the executor cores configuration. And as we said, if we specify that we want more cores than are available, then of course not everything would be able to run in parallel. So we can think of an executor as a container that runs on nodes, because each such container is a JVM. A JVM is also a kind of container, right? It contains the Java code that runs. So each such executor is a container that runs multiple tasks in parallel, and one node can have multiple executors. The number of executors that we specify in the configuration of number of executors, num-x, it's called num-executors, is global across the cluster. So the num-executors does not say how many executors I want in a machine. The num-executor says how many executors I want globally around the cluster, and the driver memory controls the memory of the driver. So to recap, the four configurations that we have discussed in Spark are num-executors, the global number of executors that we want to have on the Spark clusters, the executor memory, which is how much memory are we going to supply to each executor, the executor cores, which will determine eventually how many tasks are we going to have across each for each executor, and the driver memory, which would control the memory that we supply to the driver process, the driver node, which will actually run our main, and then our main would trigger the execution of all the Spark cores across all the executors, and over there we have the parallel configuration of the similar configuration of executor memory and executor cores.